For as long as human beings have existed, the night sky has inspired a single question: what is really out there? Long before telescopes, people looked toward the stars and searched for meaning. Ancient civilizations imagined the heavens as a perfect and unchanging realm. Constellations became heroes, monsters, and legends passed from one generation to the next. The universe seemed orderly, almost designed to be understood. As centuries passed, careful observation began replacing mythology. Astronomers tracked the movements of planets, predicted eclipses, and uncovered mathematical patterns hidden within the sky. Each discovery strengthened a powerful belief that the universe followed rules, and with enough patience, humanity could eventually understand them all. History, however, has a habit of challenging certainty. Again and again, ideas once considered unquestionable have been overturned by new evidence. Earth was once believed to be the center of creation until astronomers discovered that it circles the sun. Later, our sun was revealed to be only one ordinary star among hundreds of billions inside the Milky Way. Then astronomers realized even our galaxy was just one island in an unimaginably vast cosmic ocean filled with countless others. Every major breakthrough solved one mystery while revealing dozens more. Today, humanity stands at another turning point. High above our planet, nearly 1.5 million kilometers from Earth, a remarkable observatory quietly studies the deepest reaches of space. Unlike previous telescopes, it was built to capture a form of light invisible to human eyes, infrared radiation. That observatory is the James Webb Space Telescope. Its enormous gold-coated mirror gathers incredibly faint light that has traveled across the universe for billions of years. Because space itself has expanded over cosmic history, ancient light has stretched into infrared wavelengths before finally reaching Webb's sensitive instruments. When Webb detects those faint signals, it is doing something extraordinary. It is observing objects as they appeared billions of years ago. Looking farther into space also means looking farther back in time. In that sense, every image Webb captures becomes a glimpse into the universe's distant past. Before Webb began operating, astronomers already possessed an impressive understanding of cosmic history. Earlier space telescopes had shown that the universe contained unimaginable numbers of galaxies, each filled with billions of stars. One famous observation forever changed astronomy. Scientists pointed a telescope toward what looked like an empty patch of sky, a region so small it could disappear behind a grain of sand held at arm's length. At first, nothing seemed to be there. But after days of collecting light, darkness transformed into thousands of galaxies. What appeared empty was actually overflowing with distant worlds. That single observation reminded humanity of an important lesson. The universe is often far richer than it first appears. Still, even those remarkable images had limits. The earliest galaxies remained too faint and too distant to study in detail. That was exactly the challenge Webb was built to overcome. Scientists expected clearer pictures, more precise measurements, and better confirmation of existing theories describing the young universe. Instead, Webb delivered something far more exciting. Its first deep observations revealed enormous numbers of ancient galaxies that appeared surprisingly bright. Many of these systems existed when the universe was only a small fraction of its current age. That alone was remarkable. But another detail attracted even greater attention. Some of these galaxies looked far more developed than researchers expected. Instead of appearing as tiny, irregular collections of stars still struggling to form, several displayed signs of organized structure and substantial mass. Astronomers immediately began asking difficult questions. How could galaxies grow so quickly? Were stars forming at a much faster rate than predicted? Or did existing computer models underestimate how efficiently matter gathered during the universe's earliest chapters? These observations did not prove that modern cosmology was wrong. Instead, they highlighted areas where scientific models might need refinement. That is exactly how science progresses. A theory is never considered beyond question. It survives only as long as it continues matching new observations. Whenever better evidence appears, understanding evolves alongside it. Webb continued providing even more clues. By separating light into detailed spectra, astronomers could identify the chemical fingerprints of distant galaxies. Elements such as oxygen, carbon, and nitrogen appeared in places that existed surprisingly early in cosmic history. These heavier elements cannot appear immediately after the Big Bang. They are forged inside stars and released into space only after generations of stellar evolution. Finding them so early suggests that stars may have formed, lived, and died more rapidly than earlier estimates suggested. Exactly how rapidly remains one of astronomy's most fascinating questions. Far from creating confusion, discoveries like these are helping researchers build a more complete picture of the universe's earliest evolution. Each observation becomes another piece of an enormous cosmic puzzle. And as Webb continues looking deeper into space than any telescope before it, one thing is becoming increasingly clear. The universe still holds far more surprises than anyone imagined. And some of Webb's most astonishing discoveries may still be waiting among the oldest light in existence. Every answer the James Webb Space Telescope uncovers seems to lead to an even bigger question. That may be its greatest achievement. Science has never been about proving that we already know everything. It has always been about discovering how much remains unknown. And with every new observation, Webb reminds us that the universe is still full of mysteries waiting to be explored. One of the most remarkable discoveries emerging from Webb's observations is not a single galaxy or star, but the enormous structure of the universe itself. On the largest scales, galaxies are not scattered randomly across space. Instead, they gather into an immense network known as the cosmic web. Imagine billions of galaxies connected by gigantic filaments stretching across hundreds of millions of light years. Between these filaments lie enormous cosmic voids, regions containing very few galaxies at all. Together, these structures create the largest known pattern in the universe. But something invisible appears to be holding this vast network together. Astronomers believe most of the universe's matter is made of an unseen substance called dark matter. Unlike ordinary matter, dark matter does not emit, absorb, or reflect light. No telescope can photograph it directly. Yet its gravitational pull influences how galaxies move and how massive structures form over billions of years. Without dark matter, many of the galaxies we observe today would simply not exist in the way they do. Even so, dark matter remains one of the biggest unsolved mysteries in modern astronomy. What is it actually made of? Why has no experiment detected it directly? And could there be entirely new physics still waiting to be discovered? Webb cannot answer all of those questions by itself. But every new observation helps scientists test competing theories and improve their understanding of the invisible universe. At the same time, Webb has opened another exciting chapter in astronomy: the search for worlds beyond our own. Only a few decades ago, planets orbiting other stars were little more than speculation. Today, thousands of exoplanets have been confirmed. Some are larger than Jupiter. Others are rocky worlds similar in size to Earth. Some orbit scorching hot stars, while others circle faint red dwarfs where temperatures may allow liquid water to exist. Yet seeing these distant worlds is only the beginning. Webb allows scientists to study the atmospheres surrounding certain exoplanets using an extraordinary technique called spectroscopy. As a planet passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light. By studying those tiny changes, astronomers can identify molecules floating high above worlds that are hundreds of trillions of kilometers away. Water vapor, carbon dioxide, methane, carbon monoxide. These chemical fingerprints reveal clues about the climate and chemistry of planets humanity may never visit. While none of these observations prove the existence of life, they help scientists identify environments where life could potentially exist. That possibility alone marks one of the greatest achievements in human history. For the first time, we are beginning to compare distant worlds instead of merely imagining them. Yet perhaps the most inspiring part of Webb's mission is not what it has already discovered. It is what it has made possible. Somewhere beyond the limits of today's observations may lie the first generation of stars that illuminated the universe after the cosmic dark ages. Somewhere farther away may exist galaxies even older than those already observed. Future discoveries could reshape our understanding of black holes, galaxy formation, or even the earliest moments after the Big Bang. Each new image extends humanity's view a little farther into the unknown. Every faint beam of light reaching Webb has traveled across billions of years before ending its journey on a mirror built by human hands. Think about that for a moment. Long before Earth formed. Long before the Sun existed. Before dinosaurs walked our planet. Before humanity evolved. Those ancient photons began traveling through an expanding universe. After crossing unimaginable distances, they finally arrived at a telescope orbiting far from Earth, where scientists transformed tiny signals into breathtaking images of cosmic history. It is one of the greatest scientific achievements our species has ever accomplished. Yet Webb is not revealing the final chapter of the universe. It is revealing the opening pages of a much larger story. History has taught us an important lesson. Every time humanity builds a better telescope, the universe becomes even more mysterious. The first telescopes revealed planets. Larger observatories uncovered galaxies. Space telescopes expanded our view beyond imagination. Now James Webb is pushing the frontier farther than ever before. And somewhere beyond its current reach, another discovery is already waiting. Perhaps it will explain how the first galaxies formed. Perhaps it will uncover new physics that scientists have never imagined. Or perhaps it will simply remind us, once again, that the universe is far greater than our current understanding. One thing is certain. The more we learn about the cosmos, the more extraordinary it becomes. And as James Webb continues to peer into the oldest light in existence, humanity stands at the beginning, not the end, of its greatest journey of discovery. The universe has not finished telling its story.